In my last video, I demonstrated the use of this lever action progressive beveling skill saw. And it's designed actually to cut a little bit thinner plank, and it'll tame down nice on the bench, and that system works very well. But when you're trying to cut, say, a much thicker plank out on a couple of Sawhorses, and there's certainly a reason for that, because you might get planks that are so thick and twisted and bent that they don't want to tame down on the bench. So this system kind of breaks down under that pressure, so I've designed another saw. Now this particular saw was designed to cut a plank on Sawhorses, and then you're using the surface of the plank in order to stabilize the cut. Now it lays there nice and flat all by itself. It's not overweighted on one side or the other. That would be a disadvantage. And what I've also designed on this particular saw is a different type of tilting mechanism that doesn't make it so that I have to pry down against it and maybe possibly lift it up off the outrigger like that. I've designed a threaded mechanism, and this particular threaded mechanism, one rotation of this handle is 1 degree of tilt. So if I rotate it one rotation, that'd be 1 degree. I've also got a degree readout in front of me here, so anytime I want to make reference to that, if I didn't trust the amount of revolutions I was doing, I can check to see what degree the saw is on at any time I want. So I've got 2 methods of keeping track of the degrees. Okay, so I'm going to demonstrate now the tilting mechanism. I would be taxiing along the line and picking up the degrees and rotating this as I go. That would be 1/2 degree. There's 1 degree. 1.5 degrees, 2, 2.5 degrees, 3, 3.5 degrees, and 4. It makes it very easy to keep track of it because it's 1 degree per revolution. I've also got, obviously, the degrees written down on the plank in front of me as I come along, and all I need to do is coordinate my numbers with the numbers on the plank. Got an 8-inch blade in it. It cuts 2.5 to 3-inch planking like ringing a bell. It doesn't run out of power. It's got a 24-tooth blade in it, which rips much, much easier than any kind of a finish cutting blade or anything like that, and it doesn't load up. Carbide tooth. It's really quite a mechanism. Now, as I make these cuts, you can see that I've got a batten nailed down on top of the plank that I'm cutting. And the outrigger taxis over the nails that hold the batten down. Very, very convenient, you know, because I don't need to add on any wood to put a batten way off to one side or anything. The batten's right down the middle of the piece of wood that I'm cutting. This is the cut that I've just made. Now you can see that it's very nice and smooth, that the progression becomes very nice and smooth. The top edge of the plank, or the inside edge, and this would be the mating surface between the 2 planks, and then this would be the outside edge. You don't see any transitions in it or quick shakes in it or anything like that, and that's a nice finished cut. That cut is so well done that it doesn't need any kind of fitting, adjustment, or otherwise. If the bevel has been picked up properly and you can cut it properly like this, it saves tremendous amounts of time. The only other thing left to do on this particular job here, if this were a 2.5-inch planking on, say, a large boat, would be to deduct some caulk and bevel off of it, because at this point right now, the plank would fit and mate up to the other plank all the way up to the outside surface, and that's not necessarily what you'd want in a traditional manner, so you deduct a little caulk and bevel, and it's a complete job.